Today, lesson 14C, day number 1 of volume. So we'll be working on calculating volume, which we've done all year long in the X problems, so that should make this easy. And then tomorrow, we'll deal with finding the height of shapes and finding the radius of specific shapes, which we did that in an earlier lesson probably about a month ago, so even that should be easy. All right, so let's get started. So some definitions here. Polyhedrons are closed figures bound by polygons. And we have lots of places in the notes where you're supposed to fill in some things today. So when we're talking about polyhedrons, we're talking about prisms, we're talking about pyramids, and when we name prisms and pyramids, we name them by their bases. And when we're talking about prisms, prisms have bases that are parallel to each other. So in this situation, this is a square prism because of the fact that the bases are squares. Now we could also think of this as a rectangular prism if we felt like the front and back were the parallel sides. And once again, we've got lots of places where we're supposed to be filling in things. The next shape next to that, the parallel sides are triangles, so therefore this is a triangular prism. Pyramids are also named by their bases. So in this pyramid, we have a base that is a square. So this is a square pyramid. Now, if you thought the base was a rectangle, you could call that a rectangular pyramid. Here's another pyramid that has a base that is a triangle. This is a triangular pyramid. And then we have other types of polyhedron that are made up of multiple polyhedrons. So for example, in this one, we have a prism with a pyramid on top. So there's no specific name for this. This is just a polyhedron that's made up of multiple three-dimensional shapes. And then we have three-dimensional shapes that are non-polyhedrons. And the reason is because they're not made up of closed figures bounded by polygons. So we have cylinders and cones and spheres. A polygon is a shape with sides. Well, it should be clear to you that a cylinder doesn't have sides. It has circles instead of polygons. All right? So we typically refer to this as sometimes we call it a right circular cylinder, sometimes just a cylinder. And then sometimes we have cylinders that look like somebody sat on the corner of it and squished it sideways. We call that an oblique cylinder. And then we have sometimes regular cones. Sometimes it's called a right circular cone. Sometimes they're sitting like a regular cone, sometimes they're sideways. And then, of course, we have a three-dimensional circle, if we want to think of it that way, that is a sphere. And most of these things, I know all of you knew that. All right, continuing on, prisms and cylinders, which we've talked about before. To find the volume of either a prism or a cylinder, it is the area of the base times the altitude. Now, you may have heard of it at times the height. I don't like to call the height because sometimes students get mixed up the height of a base confused with the height of the actual shape. So I refer to how tall a shape is by its altitude. So if we had this shape, which is a rectangular prism, we would find the area of the rectangle and multiply it by how tall it is. And some of you were given in 6th grade as the length times the width times the height, which you could think of it that way. In this one, we have a triangular prism, so we would find the area of the triangle and multiply it by how tall it is, which once again I'm referring to as the altitude. And I hate even throwing these formulas out there because I prefer you to just think of it as the area of the base. Find the area of whatever the base is and multiply it by how tall it is. But I am going ahead and throwing those out there. And then we have a cylinder here. The base is a circle, so we need to find the area of the circle and multiply it by how tall it is. And sometimes these shapes are laying sideways, so the height or altitude of that shape is actually sideways instead of vertical. All right, and then a little review of things you've talked about over the last 3 years. You've talked about perimeter and circumference. When we're talking about perimeter or circumference, It's the distance around a shape. And in real life, it might be finding the amount of fencing that will go around a yard. Area and surface area, for that matter. When we're talking about these things, we're talking about the amount of space that covers a region. So, for example, when you get older and you buy a house, if you want to figure out how much carpet will go in a room, then we're talking about area there. And more areas or more spots in your notes where you're supposed to be filling things in. And then the newest thing was volume. Volume is the amount of space enclosed within a region. If you want to figure out how much water fits in your water bottle, that's an example of volume. Or if you have a pool, how much water will fit inside that pool? That's an example of volume. How much air will fit inside of a balloon? That's an example of volume. The amount of space enclosed within a region. So today I'm not going to ask you just find the volume. I'm going to ask you questions like our ask number 1. How much dirt will fit inside this container? That's an example of volume. Find out how much dirt will fit in that container. And to find the volume of any prism or cylinder, it is, remember, the area of the base shape multiplied by the altitude. Now, there are no units there, so we would just say cubic units. So, for example, Leah, what's the volume of this shape? Or, let me rephrase it. How much dirt will fit in that container? 350 units cubed. The area of the base is 50 because it's a rectangle. Multiplied by how tall it is 350 cubic units. Number 2, how much water will fit in this trough? A trough is a container that fits usually some sort of liquid. The parallel congruent shapes are the trapezoids. So this is referred to as a trapezoidal, probably one of the harder ones to say. It's a trapezoidal prism. So we need to find the area of one of the trapezoids. To find the area of any trapezoid, remember, it's the sum of the bases, and the bases are the parallel sides. And since we have 5 right here, obviously this is also 5. So it's the sum of 5 and 11 multiplied by the height of that trapezoid, which is 4, and then we take half of that, and then we have to multiply that by the altitude. This is a trapezoidal prism that is lying on its side, so 8 is the actual altitude of that shape. So when we put all of that together, we end up with something like this, and we should end up with a volume of 256 cubic units. So 256 cubic units of water will fit inside that trough. Let's continue on. How much liquid will fit inside this cylindrical tank? Everybody try number 3. To find the volume of any prism or cylinder, it's the area of the base shape multiplied by the altitude. So in this case, the area of the circle multiplied by 9, since that is the altitude. To find the area of any circle, it is the radius squared multiplied by pi. The diameter is what's given in that circle, so we have to find the radius. The radius, of course, is 4. But I have some advice for all of you, and I know I've talked about this before, but any shape that involves a circle, if I were you, I would leave whatever you're finding, surface area or volume, in terms of pi until the very end. It just makes things a lot easier. And that's kind of how I will deal with all shapes today that have circles in them. So to find the area of a circle, it is going to be pi times 4 squared, because the radius is 4. 4 squared is 16, so we now have 16 pi times 9. Notice that I've left pi as pi. Now I'm going to multiply using the commutative property 16 times 9, and that gives me 144 pi. So at this point I haven't done any sort of multiplying by any decimal. It is now that I will do that. And another reason why I do that is sometimes you're simply asked for the volume or the surface area in terms of pi. So in terms of pi, the volume is 144 pi. Now I can multiply 144 times the decimal value of pi, which of course is 3.14, and that would give me a volume of 452.16 cubic units. All right, so far easy. Sometimes, and I'm not asking you to actually do both of these, but I just want to talk about them. Sometimes we're already given the volume, or excuse me, the area of the base shape. So like in the left-hand side, which the base there is a hexagon. So we say that this is a hexagonal prism. The area of the base, the hexagon, is 40 units squared. This has an altitude of 7, so that would make the volume of this 280 cubic units. And just because we have a shape like the one on the right that is pushed sideways, which this is called oblique, so this is an oblique pentagonal prism, it doesn't change the volume. So the base area is 26, and we multiply that by the altitude. So I just wanted to talk about that in case we run into a shape where you're given the area of the base already. These are actually much, much easier. All right, so then sometimes we have shapes that are made up of multiple shapes. We usually call these composite figures. So if you look at number 4, we have this shape right here. I would like you to find the volume of that composite or complex prism. And in that picture, you should clearly see 2 different prisms. So in this picture, we have either a square or a rectangular prism, depending on how you look at it. The volume of that is very clear. It's going to be 36 times 10, or if you thought of it as rectangular, it would be 60 times 6, but regardless, it's that square or rectangular prism is still 360 cubic units. And then for the triangular one, what we have to see is that we need to find the area of one of the triangles. Each of those triangles have a base of 6, but they have a height of 3. And if you don't see that, it's because of the fact that we have 9 from there to there. That's what this is all about. But it's only 6 from there to there. So 6 from there to there, that means it has to be 3 from the bottom of the triangle to the tip of the triangle there. And so once we put that together, the area of the triangle is 9, and then we multiply that by the height of that, which is 10, and that would make 90 for the triangular prism. And so the total volume of that shape is 450 cubic units. All right, let's keep going here. Number 5, find the volume of metal needed to make the cylindrical tube. So basically what you have here is I'm going to try and color this in, but there's a tube right there. So in other words, it's hollowed out. You can kind of think of it as a straw if you wanted to. But you're trying to figure out how much metal it will take to make that tube. I want you to work on that with your shoulder partner. All right, so we just had a good question here, and that was, and I'm not sure if it's coming up in the next transition or not, but this metal tube should be 30. Should have an altitude of 30. So most of you realize what you needed to do is you needed to find the area of the outer circle and take away the area of the inner circle, because it's a metal tube where the middle of it has been cut out of it. It's been taken away from it. So that does make sense. And remember, the 30 was left off for whatever reason, but that's how tall this metal tube is. So let's go through this. And I'm going to leave things in terms of pi. So it'll be the outer cylinder, take away the inner cylinder since it's cut off. And the outer cylinder has a volume of 1470 pi. Once again, I'm leaving it in terms of pi until the end. The inner cylinder has a volume of 1080 pi. The reason why I leave it in terms of pi is that now I'm going to subtract those two like terms. 1470 pi, take away 1080 pi, leaves me with 390 pi. Doing it that way, I only have to deal with a decimal one time, and that's right now. And when I multiply that out, it should be 1,224.6 cubic units. All right, any questions with regards to this problem? All right, let's continue on now. Pyramids and cones. When we're dealing with a pyramid or a cone, the volume is 1/3 the base area times the altitude, and we'll see that in a few problems. I'll show you why that is what it is. This is not the first time we've seen things like this. These have been on X problems all year long. So if we wanted to find the volume of this square pyramid, it would be 1/3 the area of the base times the altitude. And if we wanted to find the volume of this cone, we would find the area of the circle. Take 1/3 of that and multiply it by the altitude. So here's what I want you to do. I want you to quickly do number 6, 7, and 8. Once again, do 6, 7, and 8. Number 6, we have a square pyramid. So we find the area of the square, multiply it by the altitude, take 1/3 of that. That would leave me with 384 cubic units. Number 7 is a 1, 2, 3, 4, 5 pentagonal pyramid. Another one that's tough to say quickly. So we find the area of the pentagon, which is given to us, multiply that by the altitude, and take 1/3 of that. That would give me 120 cubic units. All right, and then we have a cone. How much stuff will fit inside that cone? We find the area of the circle, multiply it by the altitude, take 1/3 of that. Notice that I continue to leave things in terms of pi until the very end. And the reason why I do that is it just makes things much, much easier. All right, 113.04 cubic feet of stuff will fit inside that cone. Now, where does the 1/3 area of the base times the altitude come from? Well, let me show you. If I have a cylinder and a cone that have the same base area and the same altitude, and I find the volume of each and leave them in terms of pi so that you can clearly see that it is going to be 1/3 as big. So what does that mean? Well, if there's water in the cone, I could fill 3 of those cones up and pour them in the cylinder, and 3 full cones would fit inside of the cylinder. Now, in the next problem, if you look at it, it's basically like a cone on top of a cylinder. We're not going to find the volume of that, but can everybody look at the next problem? And it says how much grain will fit in the silo. A silo is like a big, huge container. I want you to just quickly talk about how you would go about finding how much grain will fit in that silo. You got about 30 seconds with your shoulder partner. So in this silo, if we want to find out how much grain will fit in there, we find the volume of the cone and the volume of the cylinder, and we would add them together because the cone is on top of the cylinder, and so we're going to add those two together because it's total volume of both shapes altogether. And notice that I continue to leave things in terms of pi until the very end. Now I'll deal with the 3.14 aspect, and so there's 3,692.64 cubic feet of grain that will fit in that silo. All right, we end today with spheres, which we have in the X problems we have dealt with before. To find the volume of any sphere, and I'm leaving this up there because I know a few people are copying down what they need to copy down. It is 4/3 times the 4/3 times pi times the radius cubed. 4/3 pi r cubed to find the volume of any sphere. I would like all of you in the first problem there to go ahead and find the volume of that sphere. The radius of that sphere is 3. Find the volume of it. So in this sphere, we have a radius of 3 units. It's 4/3 pi times the radius cubed, so 3 cubed, which is 27. And then I typically would go ahead and multiply the 4/3 times the 27. And the reason is because 3 goes into 27 evenly. And I leave it in terms of pi as long as I can. And so that would give me 36 pi. And then 36 pi is 36 times 3.14. So the volume of this sphere is 113.04 units cubed. All right. Everybody go ahead and do number 10 and number 11, and then we'll talk about all of these shapes that we've talked about today. Number 10, we have a diameter of 12. We need the radius, though, so that would mean that the radius that we need in number 10 is 6 units. And when we put all of that together, we end up with 288 pi for the volume, or as a decimal, 904.32 units cubed. So that's how much helium will fit in that balloon. And number 11, we are given the radius, which is 9. Piecing all that together, 972 pi in terms of pi, and 3,052.08 units cubed. That's how much helium will fit inside of that balloon. So now, a quick comparison, and you've got some things that you need to fill in here, and then I have one last question for you. Comparing cones to hemispheres. By the way, a hemisphere is half of a sphere and a cylinder. So if I have a cone and a hemisphere and a cylinder, they all have the same exact base area. In other words, they have the same radius. For a hemisphere, it's not a base. Well, actually, it is a base in terms of this hemisphere. And they also have the same height, which happens to be the radius as the height. If I find the volume of the cone, it would be 1/3 pi r cubed. If I find the volume of the hemisphere, I end up with this. Volume equals 2/3 pi r cubed. If I find the volume of the cylinder, its volume equals pi r cubed. In other words, it's really 3/3. 3/3 is 1 pi r cubed. So the question is this. The question is, how many cones equal 1 hemisphere? 2 of them. Think about it. 1/3 pi r cubed, 2/3 pi r cubed. 1/3 and 1/3 is 2/3. So 2 of those cones will fit inside the hemisphere. How many cones equal 1 cylinder? By the way, I've already kind of talked about that. How many? 3 of them, or 3/3. But my last question to you is, if I extended this out to a sphere, how many cones are equal to a sphere with the same radius? 4 of them. And that's where volume equals 4/3 pi r cubed. Cone, volume equals 1/3 pi r cubed. Hemisphere, volume equals 2/3 pi r cubed. Cylinder, volume equals 3/3 pi r cubed. And sphere, volume equals 4/3 pi r cubed. Okay? All right, we are finished for today.